In this video we continue with 3D rendering, now moving on to fused PET-CT rendering. As you can see on the right hand side of this slide, the combination of a surface rendering from the CT with volume rendering of the PET data can make quite a pleasing result and highlight things like the lesions that we see in this particular example. So we return to the 3D tool, where we still have the previous rendering from the last exercise in the buffer. Using the cross on the right hand toolbar, I can clear all of the data, and then I can go to the DB Load tab, where I can select the data that we will work with. Again, this is the demo database, the subject PSEG2, and in this case we'll take both CT and PET. The CT masked is our version of the CT without the bed, so we'll use that again. And we'll use the PET 3D that has been resliced to the CT matrix so that the renderings match properly. On the NZ and NX and Y columns in the database series entries, we can see that the resolutions match properly. Once I've selected both images, I can open, and then we will be taken to the Segmentation tab. As before, the images appear in the top left on the Input tab. Using the small arrow below the Image Information button, I can select which image is currently displayed and therefore which one the segmentation will be based on. I'll start with the CT. And to start with a surface rendering of the skeleton, this will be a similar process to the last exercise. I can use the simple threshold-based segmentation method, enter my threshold of 500 Hounsfield units, and then run the segmentation. And as before, we see the segmentation result in the top right on the Current tab, and the MIP reveals an overview of what that segment looks like. I can then add that segment to the list for rendering and set its properties, changing the color and the name as I want. So we stick with surface rendering. As before for the skeleton, I will change the color to pure white. And I'll change the name to skeleton. Then I can go ahead and render the skeleton, and then we'll come back and prepare the PET data for rendering. So once the rendering has been generated, we can go back to the Segmentation tab. Now, using the arrow that I showed you a moment ago, I'll change the image from the CT to the PET. And I can explore the image with the data inspector to understand the thresholds that I want to work with. In this case, with the data inspector, I want the uptake in the lesions and in the brain to be displayed, but I might want to avoid high uptake in the bladder. So if I use the data inspector to explore the values in the bladder, we see that they're relatively high, in the range 40 to 45, while values in the rest of the body are below 5, with some peaks in brain and the lesions. In that case, to get a rendering that includes everything I want but excludes the bladder, I can change the thresholding method. Instead of the simple threshold, I can change to in range. And I can set a range between 1 kilobecquerel per cc and 30 kilobecquerel per cc. If I run the segmentation for that, then on the Current tab in the top right, we see that we've outlined much of the body, but if we click at the appropriate location, we can see a hole where the bladder was. Next, we add this segment to our rendering list. And again, we can set the properties. In this case, I will select the volume HD method with the color table cold selected from the list, and I will change the segment name to PET. Then I confirm. To add this volume rendering to what we have already, I should make sure that the append pin is active, and then I can render selected. Now we see the combination of the skeleton in surface rendering with the PET volume rendering, and we can adjust that volume rendering as well as add the VOI and then plan what's next. The prominence of the lesions and the PET data in general can be adjusted by changing the color transfer function settings for the volume rendering. So I can select the volume rendering on the View tab in the top right, and then on the Volume tab I can adjust the bar below the main color transfer function, dragging down the upper boundary to about 50%, and that will then update the volume rendering. As you can see, we now have brighter colors and we see the lesions in the armpit and the myocardium more clearly. Now we can add the volume of interest, the same as in the last exercise. So we can go to the Input tab on the top right. Then we can select the VOI for the heart from the database. Use the search terms, enter subject PS, and update to see only the entries for the PSEG2 subject. And we can select PET derived heart. Then again, make sure that the append pin is active, change the rendering mode to VOI's surface, and confirm the rendering of the VOI. And we see the same yellow volume of interest appear in the heart. Finally, we can trim the top of the skull in the surface rendering to reveal the PET uptake in the brain. To do that, we should select Planes on the View tab. Then on the Planes tab that appears in the lower right, we can add an oblique plane. Initially the plane is displayed cutting through the image in the wrong direction. So I should use the arrow that appears through the plane to rotate it so that I can trim just the top of the skull. These rotations and movements of the plane can be a bit iterative, so just keep moving it and then adjusting the image as required. So in the first shot I was able to move the tail of the arrow closer to the skull. Now I should select it again, and I can drag the tail of the arrow right through into the top of the skull. Next I should move the plane, so I can click on the plane itself with the left mouse button and drag its position up the subject until it transects the top of the skull. And now the tail of the arrow is above the skull, the plane in the correct position, and the arrow itself moving through the body within the rendering. To trim the surface rendering, I should select it in the list in the View tab. Then I can select the Cut tab in the lower right. Because the tail of the arrow is on the side of the plane that we want to cut, in other words we cut the top of the skull, I can deactivate the arrow side tick and then select Cut to trim away that portion of the rendering. This will take some time depending on the processing speed of the system. Once the cutting is complete, we can hide the plane so that we can see the rendering in its completeness again. In that case, on the View tab, I select plane 1 that was created, and then on the Planes tab below I can uncheck Visible, and now we see only our rendering of the skeleton with the PET data. Again, we can explore the rendering with the left mouse button, dragging the mouse around. And on the Scene tab, Rotation, we can capture a rotating movie around whichever axis we prefer. In this case, I'll just illustrate capturing a QuickTime movie with 8 frames per second. We see the rotation play through, and then it will give me the save dialog.